Good day, Professor. This is my version of an environment probe for exploring Europa's ocean. So the mission, we plan to send a submersible under Europa's surface ice to explore the subterranean ocean. When doing this, we're going to need a pretty good look at our environment. Thus, we're going to make an environment probe that has 4 sensors that are a thermometer, a pressure sensor, a salinity meter, and a pH meter. These will give us a good look at the environment in the ocean. So, the first is a thermometer. It uses a thermistor's changing resistance to read temperature using a voltage divider circuit. Temperature goes up, resistance goes down. This can be measured digitally. A pressure sensor uses a foam material with graphite to raise or lower the resistance between 2 wires. It works on contact resistance. So when you squeeze the piece of foam, the contact increases between the 2 wires through the graphite, which lowers the resistance, and that can be measured through a voltage digitally. The salinity sensor uses 2 wires at a known distance to measure the changing resistance of water. Water, and any fluid for that matter, is measured in ohm times unit distance. So as water gets saltier or has more minerals, the conductance goes up. It conducts electricity better, which means that the resistance gets lower, which can be measured digitally. Finally is the pH sensor, which uses a concentrated KCl solution sealed in a glass bulb to measure voltage across a reference node. Bad picture, you can't see the reference node on the other side of the bulb. The hot glue, you can't really see it. But it uses a concentrated KCl solution to check the resistance, but really it's to measure the voltage across the reference node and the node inside the bulb. So, one issue we had was that when we were testing our sensors, we would have crosstalk between the two. So I would squeeze the pressure sensor and we would be getting a change in the thermometer. Not good. So we fixed this issue by combining the sensors circuits in parallel, and this prevented all kinds of crosstalk. So we got lucky. By we, I mean myself and you. You're on for the ride. So then we displayed the data in MATLAB. It used about 80 lines. I think it was actually like 76. It used 80 lines of code, and the data was able to come to MATLAB from Arduino, and it could be viewed effectively using a results viewer that I had made. So that's it for this. Stay tuned for the device presentation. So we just started a new run. If you see on salinity, it's in a 0% water solution. It's reading about 0. If I move it to 0.5% salt solution, see our reading jumps to about half, a little less, but it's about half. It was using 3%, now it's 5, a little 0.5%. Pressure, it's at 1 atmosphere. Squeeze our pressure sensor and make a pulse, you know. Temperature, it's been steadily reading the temperature the whole time. You just got to click on it to update the values live. I hold the thermistor between my fingers, and our pressure rises. Our temperature rises, not pressure. It's not smooth because I'm kind of moving the thermistor around, no big deal. pH, we click on a live view of pH. Currently the pH probe is in filtered tap water, so it's pH about 7. We're reading just under 7. Either way, 4 working sensors, and a great way to view it. Sadly, there's just not 4 live feeds. You have to click on the live feed you want.